Hello friends, welcome back to our channel. So today we'll discuss about one more concept in our machine learning, that is proximity between binary patterns. So already in our previous sessions we have discussed about the proximity measures. So that means if you are comparing two objects, so how similar they are or how far apart from each other. So that is called as a proximity. Now in today's session we'll see the same proximity between binary patterns. So we all know about the binary patterns, which will be represented with either zeros or ones. So let's start the session. Proximity between binary patterns. So this proximity means similarity check, similarity measure. So similarity measure means both are similar objects. Both here means objects, whatever the objects we are comparing. And another one is how far apart each other. So what is the distance? And also we have seen the different this measures, similarity measures also. And here the binary patterns, one more term we are seeing is a binary patterns. So this will be a group of zeros or ones, either 0 or 1. So that we are calling it as a binary, right? So for example, let us have some questions. So if you are talking about a student performance or student attendance, not the performance, we can see student attendance. So this can be represented with either absent or present. So the same binary, that means binary means anything is having only two answers, right? So here absent or present. So similarly, course completion by the student, that can be yes or no. Okay, so like that, in different perspectives we are going to use these zeros and ones. So in some concept we'll be using the same zeros and ones as absent and present. In some cases we'll be using yes or no. In some cases we'll be using it as a true or false, right? So the binary patterns, in between the binary patterns, how we can calculate the measure, I mean similarity measure. So how we can know how much similar the two objects are. So here this particular binary is divided into two terms. One is symmetric binary variable and another one is asymmetric binary variable. So two categories of variables, binary variables. One is a symmetric binary variable, another one is a asymmetric binary variable. So we'll see what is a symmetric variable and what is a asymmetric variable. Okay, let us take an example. So we are comparing the two students. Okay, let me explain the complete thing with a simple example. So I'll write here example. In this example we are comparing two students. Okay, for example, the courses, different courses available are C, C++, Java, Python, data structures, machine learning, and AI, right? For example, let us take here let us take a simple machine learning and AI. So student A, how it can be represented? So if the student A is completed the course of any one of the thing, you can represent it with 1, and if the student doesn't complete the course, it will be represented as a 0. So let us take student A completed the C course, C++ course, Java no, Python yes, ML no, and AI yes. Similarly, coming to the next student, that is student B, C yes, C++ yes, Java, Python, ML, and AI. So let it be like this. Okay. So in this, 1 represented completed the course and 0 represented not completed. 1 completed and 0 not completed. Now this can be represented as A with all these vectors. So 1 comma 1 comma 0 comma 1 comma 0 comma 1, and B can be represented as 1 comma 1 1 1 0 and 1, right? So if you are comparing these two things and we are talking about the binary representation, there will be 4 possibilities. What are the 4 possibilities? I'll write here. What are the 4 possibilities we are writing? So student A and student B. The first possibility 1 1. So we are comparing these two. See, these two will be compared. How we can compare it? So 1 and 1. So here the result is either only 0 or 1. That means one is completion, another one is a not completion. So consider 1 and 1 means both A and B have completed the course C. I mean completed the course. Either it can be C or C++ or Java. Okay. So this category we can represent it as A. Example. So next one 1 0. What it mean? If you consider any course, that course is completed by the student A but not completed by student B. So this is one more category that we can represent it with a B. And take the third one. If you consider any course which student A was not completed but student B has been completed. So this we can represent it as C. Similarly 0 0. That means the same course was not completed by both A and B students. So this is a D. So if you are comparing any binary patterns, we will be having only 4 cases: A, B, C, D. Case A, case B, case C, case D. Now what happens here? So we need to compare the same things. So coming to the different categories, just now we have seen different categories. So what are the categories just now we have explained? So first one is a symmetric binary variable. Symmetric binary variable. So what is a symmetric binary variable means? So here there will be equal importance for 0 and 1. 0 and 1. Here we are talking about both 0 0 matching and 1 1 matching. This is more important. Okay, 0 0 matching and 1 1 important. That means here this is completely 0 and this is completely 1. So both students have not completed the course and both students have completed the course. So in both the cases we are giving the equal importance in this particular symmetric binary variable. So the one example for this particular symmetric binary variable is simple matching coefficient. So this is a one of the measure we'll be using for symmetric binary variable. Okay, so we shortcut we will call it as a SMC. SMC is equal to, so what we'll be writing is nothing but A plus D divided by A plus B plus C plus D. So what is here? A plus D, A, B, C, D. So here A means 1-1 matching. Okay, agreeing for both the students. D means not agreeing both the students. So we are giving equal importance and we are taking it as a numerator. So A plus D divided by the complete values, whatever the values we are having. So in this case, you can see A is equal to how many cases? The 1-1 matching are there. So this is a one case, C, C++, Python, AI. So how many values are there? So 4 values are there. So that means 4 courses have been completed by both A and B. Okay, hope you understood. Here 4 courses were completed by both the students A and B. Next, 1 and 0, that means the first student completed and the second student not completed. You can consider 0. Next, first student not completed and second student completed. See, this is one case, only one case is there. C is equal to 1. And both are not completed. So, this is also 1. Now, what we can do? Apply this formula, SMC, simple matching coefficient, where we are giving the equal importance for both the 0-0 matchings and 1-1 matchings. Right? So, here A plus D means 1-1 matching as well as 0-0 matching. 4 plus 1 divided by A plus B plus C plus D. How many parameters? 4 plus 1 plus 1. That means 6. So it will be 5 by 6. So this is the measure, a similarity measure between the students A and B. Right? So almost equal. Okay. So that will be around 0.8. 0.8 is the similarity between the students A and B. Okay. So here the equal importance will be given for both 0-0 matchings and 1-1 matchings. That's the important. So this is the only measure we will be using for this kind of symmetric binary variable. Now the second option, so I am erasing this one. So I'll write here A is equal to, so 1, 1, 0, 1, 0, 1. And B is equal to again 1, 1, 1, 1, 0, 1. Yeah. So I'll erase this one. So what we are saying, so this is a C, this is a C++, this is the Java, this is a Python, this is a ML, and this is a AI. These are the courses. And the second category, asymmetric binary variable. So here we'll give importance to only 1-1 matching and ignore 0-0 matchings. So previously we are considering and giving the equal importance for both 1-1 matching and 0-0 matching. But here we are giving importance only for the 1-1 matching. We are just ignoring the 0-0 matching. So why we are ignoring the 0-0 matching? So see, consider any e-commerce website. So this will be having some thousands of products. For example, customer 1 have purchased one product. Customer 2 have purchased only one product, different product. See here, the 1-1 matching will be very less and 0-0 matchings will be very more. Okay, so that means only one product has been purchased with both customer 1 and customer 2, and remaining 999 products have not purchased. That means 1 1 matching is only 1 and 0 0 matching is 999. Even though, see, what happens? We are saying that simple matching coefficient will be a plus d. So obviously 1 plus 999 divided by, and this is 1 plus 999, so that is 1000 is equal to 1. That implies both the cases, I mean both the customers are similar. So we can't say that both customers are similar, because here the false case is more. Okay, so that's why in this case asymmetric binary variable we are ignoring the 0 0 matching, so we are only considering the 1 1 matching. So we are giving the importance for only 1 1 matching. So here there are three measures we can use for this particular asymmetric binary variable. So measures we can use here are, so one is a Jaccard measure, dice measure, similarity measure, overlap, quotient measure. So let us take one by one. So coming to the Jaccard measure. So Jaccard between A and B, student A and student B, that can be considered as, so only we are considering only 1 1 matching. So it can be considered as 1 1 matching divided by, and except we are ignoring the 0 0 matching. So 1 1 matching plus 1 0 matching plus 0 1 matching. So here I am representing 1 1. 1 1 means matching. Okay, it's not a 1 minus 1. 1 to 1 matching. Okay, so this can be represented as, you can see A divided by A plus B plus C. Simple formula. So A is 1 1 matching, B 1 0 matching, C 0 1 matching, and D it's a 0 0 matching. So the formula, by using this formula, what we can do, so 4 divided by 4 plus 0 plus 1, which becomes 4 divided by 5. Okay, so here we are getting 0.8. Okay, the similarity between the students A and B. Now similarly, going with the next, that is a dice. As we know, the dice formula also similar to our Jaccard. Okay, but giving weightage for 1 1 matchings. So here we'll see dice measure, similarity measure. So D of A comma B, students A comma B, will be 2A divided by 2A plus B plus C. We are ignoring the D. So 2A, A means 1 to 1 matching, B means 1 0 matching, 0 1 matching. So here you can see 2 into A, that means 8 divided by 8 plus 0 plus 1, which becomes 8 by 9. So this is the similarity between the students A and B. That's a dice distance. Okay, and coming to the third, so here also you can see we are ignoring the 0 0 matching. We are giving a more priority to 1 to 1 matching. Next, overlap coefficients. So we have seen the importance and how it will be measured in all these cases, Jaccard, dice, and overlap coefficients in our previous session. So I'll post the link in the description, so just go through that one, so you will be getting an idea. So next, the next one is the overlap coefficient. In this overlap coefficient, we will be considering the minimal set. So the overlap of A comma B, the students A comma B, will be, so A divided by minimum of A plus B comma A plus C. So here also we are not considering D. So completely in all these three cases we are ignoring the 0 0 matchings. So here you can see A means it's a 4 divided minimum of A plus B, which is a 4, and A plus C, which is a 5. So which becomes 4 divided by 4, it is 1. So it implies both the students are similar, because majority of the courses have been completed by both the students. So according to the overlap quotient, so the similarity is same. I mean the similarity between the two students are equal, right? So these three measures, so one is a dice measure, Jaccard measure, and overlap measure, will be used to measure the similarity for asymmetric binary variables, right? So two things, binary symmetric and asymmetric. And what are the applications where we can use these kind of measures in comparing or in between these binary patterns, particularly binary patterns? So the first one is spam detection, spam mail detection. Simply we can call it as a spam mail detection. So here we can consider there will be only two cases. One is either spam or not a spam. So spam or not spam. So there's a binary. Okay. Next, image processing or recognition. So that will be pixel on or off. If it is an image, we'll be calling it as a, I mean, we'll be considering the pixels. And the next one, medical diagnosis. So it represents whether it is affected or unaffected. Okay, disease affected or unaffected. Disease or no disease. Similarly, search engines. Search engines. So here also the keyword, whatever the keyword we are searching, word exist or not exist. So these are different applications where we can use all these similarity measures. Okay, particularly in the binary patterns, between the binary patterns, right? So hope you understood this proximity measures between binary patterns. Okay, we have seen two types. One is a symmetric, another one is a asymmetric. So I'll stop here, and if you are having any queries regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. And if you really enjoyed the session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.